Now we would like to talk about how to rationalize the process of rationalization means to get rid of radicals. And for the most part, we usually rationalize denominators. So that means we get rid of radicals from the denominator. But you could also rationalize numerators by applying the exactly same procedure that we're going to be applying in these examples for rationalizing denominators. You could rationalize numerators. Okay, so again, rationalizing the denominator means to get rid of the radicals from the denominator. So if you have an expression that has radicals on the denominator, such as this one over square root of 5, means I would like to rewrite this in another way, in such a way that there's no more square roots on the bottom. Okay, and the idea for this is to use the following fact, that the square root of a number by itself, so the square root of a times the square root of a, gives you back the number. So for example, the square root of 5 times the square root of 5, well, there's the properties of radicals that says that I can combine these two together. So this is square root of 25, which is 5. So in other words, square root of 5 times square root of 5 is 5. So and this happens always. Whenever you have a square root of a number and you multiply by itself, the radical disappears and gives you back the number. That's true for all a's that are non-negative. Remember, you cannot take the square root of a negative number if you want it to be a real number. If you take the square root of a negative number, you get imaginary number. Okay, so that's the property that we're going to use all the time. So if I have radicals in the denominator of a fraction, then I can get rid of the radical by using this fact. If you take the radical and you multiply by itself, square root of, such as this one, square root of 5 times square root of 5, you multiply by itself, the radical disappears and gives you 5. So let's apply that for this. So for example, suppose I want to rationalize the denominator. Well, applying that idea, I can take that fraction and multiply top and bottom by square root of 5. I want to multiply the bottom by square root of 5 so that the radical disappears, but whatever you do to the bottom, you need to do to the top so that things are balanced. So this is what you get. Now, you multiply across. 1 times square root of 5 is square root of 5. And then the bottom is 5. Okay, using this property that I just mentioned. Square root of a number by itself gives you the number without the square root. The square root of 5 times square root of 5 equals 5. And that's it. You should double check that there's no more that you can do to simplify this. And in this, there's nothing else that we could do to simplify because you cannot cancel the 5, right? You cannot combine things that have radicals with things that don't have radicals. So that is the final answer. Okay, let's take a look at this one. 2 over the square root of 2. Okay, so start with the fraction. And we want to get rid of the radical from the bottom. So you're going to multiply top and bottom by square root of 2. Okay, and then you multiply across. Square root of 2 by itself, square root of 2 times square root of 2 is just 2. Using that property. Square root by itself gives you the number inside. And then on the top, you get 2 square root of 2. Now this one, you can simplify a little bit because you can cancel it too. You divide top and bottom by 2, and those cancel. And you get square root of 2. So the answer is square root of 2. So I cancel the 2's outside, to give me square root of 2. I can never cancel something that is outside with something that is inside the square root, okay? So, and that's it. Okay, let's do this one. 5 over the square root of 12. Okay, so all of these are really done the same way. So start with the fraction that you want to rationalize. I want to rationalize the denominator. And multiply top and bottom by that square root that I see on bottom, square root of 12. And then by doing that, on the bottom, you get 12. Square root of 12 times square root of 12 is just 12. And then multiplying across the top gives you 5 over square root of 12. And that's the end, because 5, this 5 outside, and that 12 on the bottom have nothing in common, so I cannot simplify anymore. So that's the end of that story. Well, actually, that's not entirely true, because, and you should pay attention to this, okay, that answer is correct, but it is not simplified as much as possible. And if you enter an answer that is not simplified as much as possible in the online homework system, you're probably going to get it wrong. So you need to actually simplify this. So we're going to simplify this a little bit more, because you realize that the square root of 12 can actually be broken up. 12 is 4 times 3, and square root of 4 is 2. So I can break this up into 5, and then break up the 12 as 4 times 3. And then this will give you, distributing the square root of 4 is 2. So now the 2 goes outside the radical, and the 3 that doesn't have a square root, that is a whole number, stays inside. And you have that. And now I can cancel common 2 from the top and from the bottom. So divide top and bottom by 2. If I divide top and bottom by 2, that's going to cancel and give me 1, which you don't have to write. And then dividing the 12 by 2 gives you 6. So then, writing down what is the final answer, it will be 5 square root of 3, that one doesn't do anything, over 6. Now, that is the simplified final answer. So this, even though it is correct, it is not simplified. And you should always give the final answer simplified as much as possible. Simplifying an answer is always part of solving a problem in math. It's like the default, you have to simplify. All right, and that's that. Now, you should pause the video and attempt D on your own. And then compare notes with me. Okay, let's do it. So 1 over the square root of 28. Okay, so 1 over the square root of 28. So start by writing the fraction, and then you multiply top and bottom by the square root that I see there. Square root of 28 times square root of 28, both top and bottom. Now, doing that, multiplying across, on the bottom, I'm just gonna get 28, and on the top, you get square root of 28. Okay, now that is correct, but is not simplified. So now we're not gonna make the same mistake of thinking that we were done, because you think of, can I simplify square root of 28? Think about it for a minute, and then say, okay, yeah, we can, because you can break up 28 into 4 times 7, and 4 has a square root, that is a whole number. So then that means I can break this up into square root of 4 times 7 over 28. Now, square root of 4 is 2, so the 2 goes outside and the 7 stays inside. And then you get 2 square root of 7 over 28. And that's still not simplified as much as possible because now I can cancel a 2 from the top and a 2 from the bottom. I can cancel a 2 from the top and 1 from the bottom. So you divide both top and bottom by 2. That's going to become 1, which you don't have to write in the final answer, you shouldn't. And then dividing that by 2, you get 14. Okay, so that gives me square root of 7, again, don't write the 1, over 14. I divided top and bottom by 2. So square root of 7 over 14. Now let's do some with variables. Really doesn't really change the method. You do it exactly the same way. You can do it exactly the same way. Now, however, this one is a little, even though you could do it exactly the same way, for this one in particular, there's a little bit of a shortcut because you have square roots on both top and bottom. You have the whole numerator is a square root of something, and the whole denominator is a square root of something. So you can use this property of radicals backwards. There's this property of radicals that says if you have the square root of a over the square root of b, then that's the same thing as the square root of a over b. So normally we use this way, square root of a or square root of b, and you distribute the square root over the top and the bottom, but you could use it in the other direction. So if you have a square root of a over the square root of b, you can combine those two square roots into a single square root, square root of a over b. So this problem, even though you could do it exactly the same way as we have done the other one, this one can be done by that little trick in order to simplify it a little bit first. Okay, so let's do that in here. I have other examples where you cannot do that because there's no square roots on both, but in this one we can. So this is going to be just combining those two square roots into a single one. This is the square root of 12x to the fifth over 3x. Aha. Now we can simplify that fraction inside the square root. So dividing 12 by 3, we'll cancel in a 3 from both top and bottom, we get 4. And then simplifying the x's, you have 5 on top and 1 on bottom, so you subtracting the exponents, you get x to the 4. X to the 5 divided by x is x to the 4. You subtract the exponents. Alright, and this is what we get. Now, what is the square root of 4? That is 2. And what is the square root of x to the 4? Remember how to do square roots of that. You divide the exponent by the index. The index here is 2. It's invisible. 2. So 4 divided by 2 is 2. So x to the 2. And that's the answer. Okay, so that one had a little bit of a shortcut that we could use. So now let's do a few more. Let's try this one. Rationalize the denominator. Okay, so this one is the square root of a big fraction. So we're going to use the property that I just used but in the other direction. Distribute the square root. So this is the square root of 5y, square root of the top over square root of the bottom. So now we're using the same property but in the other direction. I cannot really simplify that anymore, so that's why that's not very useful. The 5 and the 6 have nothing in common, and neither do the x cubed and the y, different variables. Alright, so now we go about the same procedure that we have done before. To get rid of the square root from the bottom, multiply the bottom by itself. Square root of blah times square root of blah. So this is going to be, we're going to take this fraction, and I'm going to multiply by the square root of the bottom. On the top, square root of the bottom. Whatever you do to the bottom, you have to do to the top. Okay, there. And that, the whole point of doing that is that now the square root disappears from the bottom, which is what we want. And for the top, you multiply across. Okay, but multiplying across, you can combine those square roots. So I'm going to combine them in the next step. Multiply across, and then you can combine the square roots into a single square root. So the inside will be 30, because 5 times 6 is 30, x cubed y over 6x cubed. So I combine both square roots into a single one. And that is in this property that says square root of a, square root of b, is the square root of ab. Okay? Alright. Now, we should think whether we can simplify this or not. Okay, can we break up 30 into a product of two numbers, one of which has a square root that is a whole number? If you think about it for a minute, you really cannot, because 6 times 5, 6, neither 6 nor 5 have a square root that is a whole number, or 10 times 3, that doesn't work either. So that means you cannot really simplify this square root of 30. But the x cubed you can, because even though you cannot divide the 3 by 2, which is a procedure for simplifying, right? Divide the exponent by the index. Index is 2. You can break up that. You can break that up and say this is 30 x squared times x times y, all that over 6x cubed. And now, this thing has a square root, a perfect square root. The square root of that is just x, assuming that x is positive. Otherwise, you have to put absolute value, but I told you we won't worry about that. All right, so x to the 1 or just x, and then the rest stays inside. 30xy over 6x cubed. And lastly, one more step. You can simplify those x's that are outside. You cannot really touch an x outside with an x inside. Okay, you can simplify those. You have one x on top and 3 on bottom. But canceling 1, you would have 2 on bottom left over. So this would be square root of 30xy over 6x squared. Or just subtract the exponent. 1 minus 3 is negative 2. The fact that it's negative, that means it's on bottom. Okay, so there you have it. Okay, and here's the last one. You should pause the video on this one and give it a shot. Okay, try that. All right, let's do it. So this is going to be, take this fraction and multiply top and bottom by the square root that I see. Square root of 11 x cubed y to the fifth. 11 x cubed y to the fifth. Okay, and then multiply across. This is 10 square root of 11 x cubed y to the fifth. And the square root disappears from the bottom, which was the whole point of doing that. Okay, now we try to simplify as much as we can. Square root of 11 cannot be simplified. You cannot even break up 11. It's a prime number. But you can take the square root of, you can simplify the square root of x cubed and y to the fifth by breaking them up. So this is going to be 10 square root of 11, and then break up x cubed as x squared, x squared x squared x, and then you can break up y to the fifth as y to the fourth, and then left over y. All that over 11 x cubed y to the fifth. And now the x squared and the y to the fourth, I can take the square root of that because I can divide 2 by 2 and 4 by 2 by the index outside. And that's going to give us 10. Square root of x squared is x. Square root of y to the fourth is y squared. I divide the exponent by the index. And then you have the leftover inside, which is 11 x y. All that over 11 x cubed y to the fifth. Okay, and now almost done. One more step. We can simplify the x's and the y's. We can simplify those. Okay, so if you have 1x on top and 3 on bottom, and you cancel 1, you're left with 2 on bottom. So it's going to be 10. And then if you have y squared on top and y to the fifth on bottom, subtracting, you have 3 on bottom. So this is going to be 11 x squared y cubed. Square root of 11x y. Okay, so we subtract the exponents. 1 minus 3 is 2. Negative 2, but the fact that it's negative means it's the bottom, so x squared on bottom. 2 minus 3 is 2 minus 5 is negative 3. The fact that it's negative means it's on the bottom, so y cubed on bottom. And that's it. You cannot cancel or combine things that are inside a square root with things that are outside of the square root. So that is the end. I cannot simplify any more. Okay, and then the last topic regarding rationalizing denominators is an example where you have two things being added or subtracted in the denominator. Okay, either you have on the bottom either a plus or a minus, but you have two terms. Okay, so this will requires a little bit of a different trick. For this, we're going to use a little formula that we're really gonna see later in more detail, but is the difference of squares formula for factoring. But anyway, you have this formula, you probably have seen it. How to factor difference of squares? This is x minus y, x plus y. Okay, and then using this formula for square roots, you get, using this formula backwards, thinking of it from this side on the left, x minus y, x plus y, this is equals to x squared minus y squared. So I just wrote the whole thing again, but backwards. All right, so this formula tells me basically, when I see it, when I look at it from this point of view, is that if I take two terms that are identical except the sign in the middle is different, then I get the first one squared minus the second one squared. Okay, and that is good because if I have something like this, square root of 5 minus 1, square root of 5 plus 1, then this formula tells me that all I'm going to get is the square root of 5 squared minus 1 squared. Okay, so you're going to get this thing squared minus that one squared. And that magically gets rid of square roots. So this would be 5 minus 1, which is 4. Okay, so whenever you have two terms that are being added or subtracted, as if they're square roots, you can get rid of the square roots by multiplying by the same thing with the sign in the middle change. So if I had, like, let's say square root of 7 minus 4, for example, if I multiply this by the square root of 7 plus 4, this is the so-called conjugate. It's like a conjugate. So if you multiply by the same thing with the sign in the middle change, this formula tells me that this would be the square root of 7 squared minus 4 squared. So square root of 7 squared minus 4 squared. That's what this formula tells me. X squared minus y squared. That's the result of multiplying these two things. And that gets rid of the square root, because square root of 7 squared is just 7, and then this is 16. So the answer would be negative 9 for that product. Okay, so that is the idea for this. If you have something like this that you want to rationalize, get rid of the radicals from the bottom, all you have to do is multiply by the same thing, but the sign in the middle changed. Okay, so you multiply by the sign in the middle, you multiply by the same thing with the sign in the middle change. And according to this formula, when you do that, you're gonna get the first one squared minus the second one squared. So this is going to give us the first one squared minus the second one squared. Okay, that's for the bottom. And then for the top, you just multiply across as usual. So 1 times that. So this is going to multiply by 1 doesn't do anything. So 1 minus square root of 2. And then you simplify as much as you can. So on the top, you get 1 minus square root of 2. And on the bottom, you get 1 minus square root of 2 squared is 2. You get 1 minus square root of 2 over negative 1. And remember what I told you about having negative signs on the bottom. If you have the bottom is negative, you can move that negative to the middle or to the top. I'm going to move it to the top. Dividing by 1 now doesn't do anything, and you can distribute this minus. So this is negative 1. Distribute the minus. Negative 1 and then plus. 2 minus gives you positive. So negative 1 plus square root of 2. Okay, that is the idea. The idea is if you want to rationalize a fraction that has two terms at the bottom that are added together or subtracted, multiply by the so-called conjugate, which is really the same thing, but change the sign in the middle. That, by that formula, that I showed you is going to get rid of the square roots. Okay, we're going to do this a couple of times more, and you'll see it's really the same thing. All right, let's rationalize this. Okay, this is a minus, but it's the same thing. You do it the same way. So multiply by the same thing that you see in bottom, but the sign in the middle changed, the conjugate. So I change sign in the middle. Whatever you do to the bottom, you do to the top. Okay, that is supposed to get rid of the square roots from the bottom. And according to the formula, it's the first one squared minus the second one squared. Okay, again, it's a difference of squares formula backwards. And then you multiply across the top. So 2 times 2 plus square root of 3. Okay, let's see what we get here. So this is 2 plus square root of 3, so I haven't done anything to the top at all. I didn't do anything there. But the bottom gives me 4 minus square root of 3 squared is really 3. The square root of 9, which is 3. Okay, so you get 2 plus square root of 3 over 1. 4 minus 3 is 1. Divided by 1 doesn't do anything, so this is just 2 plus square root of 3. And then you can distribute this. This is 2 times that, 2 times that, so this is 4 plus 2 square root of 3. You could have distributed that at the very big, at any point in time. You don't have to wait until the very end to do the distribution. You could have done it like at any previous step. You could have done it much sooner if you wanted. Right? Okay, in the very last example, you have a variable in there, but it's done exactly the same way. And I think you should give it a shot. Okay? You pause the video and give it a shot. Now let's try it. Okay, this is going to be, so I take that fraction, and to rationalize it, multiply by the same thing that you see on bottom, but the sign in the middle changed. Okay, now that's supposed to get rid of the square roots from the bottom, and it does, because according to the formula, this is the square root of x squared minus 1 squared. First one squared minus the second one squared. And then on the top, just multiplying across, you get 3 square root of x plus 1. Okay, now simplify. You can distribute now here, so that distributing these would be 3 square root of x plus 3. Okay, multiply, distribute that, 3 times square root of x plus 3 over square root of x squared would be x, and 1 squared is x. And there's nothing else to do to simplify this. That's the final answer. Okay.